Hi, I'm Chris Continanza. I'm here to talk to you about the Internet of Things and keep you from lunch. So that's my honor. So what I wanted to show you was a thing connected to the Internet. So everyone on this side who cannot see, this is an LED matrix display board. This is basically 6 pieces, and you can buy each of these as a 3x2 matrix, and they're daisy chained together. But the important part of this thing is that it's connected to the web, and yeah, so things. So things, essentially when we talk about Internet of Things, we really mean computers. And the change has been that the computers have obviously shrunk in size and increased in processing power thanks to Moore's law. Because of that, we're able to get logic in places we couldn't before, and now we're able to kind of develop this whole new generation of devices and basically real-world interactions. That's kind of what I care about. And so you have the real-world interaction side, and then you might say, hey, I have this device, I've coded it up to do some cool stuff, but I'd really like it to be infinitely dynamic or configurable from where I am sitting at home. And that's where the internet is going to kind of come in, or make something that's automatic or based off of data. These slides are really here to kind of guide the stuff. So I could use maybe this one to show the things. So as the things come up. Basically, there's 2 kinds of computation platforms you're going to deal with. There's the tiny microprocessors, and there's something that's big enough to run Linux. And so in the world of tiny, we have Arduino. We have our Spark. We have an electric imp. This is an mbed from ARM, which is a small M3 processor. And then for Linux, here's your Raspberry Pi. And there's kind of this notion that eventually Linux will make it small enough, but I actually think there's always going to be a leading edge of devices that are always going to be a little bit smaller, a little bit more efficient than something that can fully run Linux. That's going to matter to us in about 3 minutes when we start talking about protocols, because one of the big advantages of having Linux on board is you get to take advantage of the whole TCP/IP stack that comes with Linux that we've all been programming on for the last X amount of years. Actually raises a good point for a raise of hands. Who does develop server-side web software here? Yeah, all right, we're all in the club. So, I'm from the same boat. I got started with Arduino a couple years ago, just kind of having fun on the side. And actually my odyssey with Arduino and the internet began with a project called the Heroku outage lights. I was in the office one day and somebody came up to me and was like, hey Chris, I don't care what kind of Arduino crazy thing you need to do, but when our status site is red, I want the office to be red. And so this is actually as simple as kind of an Internet of Things application can get, because all this has to do is trip a relay. So this is no more confusing on the hardware side than blinking an LED. What it does on the software side is it pegs status.heroku.com has a JSON endpoint, and so it just pings that on a loop, and then whenever it says, oh, the status is red, turn the relay on. Getting this connected to the internet was easy because I was able to use Ethernet. So this is the Ethernet Shield Arduino, and that was my first internet-connected Arduino project. And it actually went really easy because I had the wire I could just plug in and be on with my life. As soon as we go wireless, things get a little bit more complicated. All right, so things. So the reason I have these things listed, Arduino, Raspberry Pi, and Arduino Yun, is that Arduino is a perfect example of a microprocessor. This handles your interactions with the real world, but doesn't say actually connect to the internet itself, which is why you need an Ethernet shield or this Adafruit. This is the CC3000 chip, which we'll actually see packaged up again in the Spark device. Also the same chip. And you can buy one in this format, which is the same format as the XB as the Wi-Fi. The Raspberry Pi itself actually has Linux on it, so you don't need, or it has an Ethernet, rather, it has its own TCP/IP stack, so you don't have to rethink a lot of the world. But to make this Wi-Fi enabled, we still have to add our own Wi-Fi chip. And then something like the Arduino Yun is, I don't have one yet because I haven't been able to get my hands on it, but that's actually kind of these hybrid solutions where you have a Linux system essentially handling all the internet side of things, and then an Arduino handling all your inputs and outputs. These things start to get complicated when you say, I have GPIO here, but I really like being able to do shields with an Arduino, so you can take a Raspberry Pi and then connect it to an Arduino and control it with something like Cylon or Johnny 5. But that tends to involve too many parts for me. So the different ways to connect to the internet with a thing, Ethernet, fun, easy, simple, but requires a wire. And part of my personal challenge is Ethernet ports are getting rarer. So Heroku moved to a new office. It turned out that there were no Ethernet ports. So I had all these fun Ethernet-based applications, and I had to convert them all to Wi-Fi. And that itself kind of informed some of this experience. So I kind of want to get to that story. When you have different ways of connecting to the internet now, so there's the Ethernet shield itself. XB is this format. It's not this chip, but it looks very similar. XBs allow you to do a mesh network. So XBs don't connect you directly to the internet itself, but an XB will usually be a first hop to connect you to perhaps a Raspberry Pi that's connected to the internet. That CC3000 chip is just a very popular chip that is directly doing Wi-Fi. I found it hard to work with, so I'm very excited to try out the Spark chip. There's a library for using that in Arduino that isn't completely polished. This project actually uses an electric imp. So if I don't break it, what I have here is an electric imp breakout board, and that is handling the Wi-Fi, and I'll talk to how the Wi-Fi communicates with the Arduino in a second, and then the Yun, like I said, is actually an Arduino with a small Linino distribution on it. And basically you have Linux handling the internet and Arduino handling inputs and outputs. So this specific example, which I feel bad because it's blocked and I don't have enough surge protector, but what this is the reason I chose Arduino is that Arduino comes with a library that easily connects to these LED matrix display boards. So that was kind of a necessary, and it was very simple when it was hooked up with Ethernet. So then I tried to use the CC3000 chip, but I actually wound up with a pin conflict in that this needed one of the interrupt pins on the Arduino, pins 2 or 3, and my LED matrix board also wanted both pins 2 and 3. So it kind of looked cool because you would just have this random splat of LEDs turned on and off, but there is no app name that is, like something dash splat. So then I met one of the guys from Xively, and he said, hey, you can use an electric imp to connect to the internet. So this is an electric imp, and what the electric imp is it's an SD card format, but it has Wi-Fi in it. So to connect an electric imp to the internet, you actually do this interesting thing where you flash, and not in the streaking sense, but in the more of the epilepsy sense. So this, if you have problems with blinking, turn away now. So this is actually how you communicate the Wi-Fi credentials onto the electric imp. So that's kind of a pretty cool way of not having to recompile the same program just because you changed your Wi-Fi credentials, which I really liked about it because it lets me kind of take this with me, go into another room, set it up on my internet device. So part of the Internet of Things and connecting stuff to the internet means you're going to have to talk protocols. TCP/IP matters again. So we don't have the advantage of having Linux running for us and just opening up a connection to the web. For some of these devices, shipping your own TCP/IP stack, specifically even with the embed, actually becomes part of the equation. And that's why I think that that does matter, and what platform you choose will make a big difference. Things like Spark and IMP are a lot more internet ready. Things like the CC3000 shield for Arduino and the embed specifically are a little bit more low level, and they ship with a bunch of C++ code that you actually have to compile your own TCP/IP stack, which is something that we may or may not be familiar with or having fun. And there's always UDP around. Don't want to leave anybody out. And then for actually application level protocols, once we have a Wi-Fi connection or an Ethernet connection, once we're talking TCP/IP, we can actually finally get back to the LAN we're familiar with, HTTP, WebSockets, and then MQTT is up here because it actually fills a need. It's very easy to talk HTTP from these devices. I actually wrote my own REST client for Arduino, which worked great on the Ethernet shield. Not so much for the Wi-Fi shield because it's a totally different hardware stack or software stack. It's a different interface, and my C++ chops are not so good with polymorphism. I was trying to pass a void pointer around, and apparently you're not allowed to do that. Yeah, so with HTTP, it's still really easy. With WebSockets, it's way less fun of a protocol. I've gotten projects going with WebSockets on the Raspberry Pi because you can actually compile, you can run Node and take advantage of stuff somebody else wrote. And that's kind of where MQTT comes in, because MQTT is a simpler protocol than WebSockets, but fits that same niche of real-time communication. I think that's it for the slide. So anyways, what I wanted to talk about was how this works, because it's kind of an example of both the trials and tribulations of building an internet-connected thing. I really wanted it to do something, so wanting it to work was a big part of it. The way this works now is there's an Arduino, and the Arduino is connected via the electric imp breakout board. Now, if you're going to want to get something online, you are going to have something like this layer. You can directly, from the Raspberry Pi, talk through the GPIO pins, so you don't have to have an Arduino per se. But if you do want to connect an Arduino, you're going to have to use either the imp shield, the Wi-Fi shield, or the Ethernet shield. And the reason I went with the imp is because it allowed me to do a software serial connection. So I have the imp is actually talking, and I'll show this code, is talking via software serial to the Arduino itself. So the Arduino sits there and it waits on a serial connection from, so that's deployer's imp serial. And without getting too much into it, right here, we set up a software serial that I call imp serial on pins 8 and 9. So the long story short there is I was able to get around the requirement that the matrix display board needed 2 pins by using the imp board and letting that speak software serial over pins 8 and 9. And the lesson there isn't that everyone should run out and use software serial, it's that there's going to be an annoying hiccup somewhere in your project. And getting around it may not be straightforward. So what I learned there was there's this protocol called UART. And UART is actually built into the imp. So the imp is running in the cloud right here. And down here are these strings. So has anyone figured out what this is actually displaying yet? Close. Heroku deploys, exactly. So people that are deploying to Heroku right now, every deploy is scrolling across this. And the reason I built that is because the outage lights was kind of a downer project. It's only working when something bad's happening. And it has to be working all the time, so I put an effort to monitor it and to make sure that it was still checking the requests and did all this productionization for something that essentially sits in a corner, gathers dust, and is good if it stays off all day. So the idea behind this was, how do I take something that's happening unvisualized and visualize it in the real world? And some of the initial ideas that came around were, hey, why don't we blink an LED every time someone deploys? Which is cool, but I figured it would have been very hard. I mean, this is blinking, right? Like, it's not really that impressive, and there's kind of a lot of explanation you have to do, like, what is this thing blinking on your desk? Why? You know, no one's really going to associate that with app names. So I figured, well, if I can figure out the name of the app while it's being deployed, it would be really cool to get a lot of LEDs together and display that. And so that's kind of what informed this project. And then some other things that I've worked on with Heroku has been like a demo of WebSockets talking to a back-end Heroku app. But, you know, that's actually where we found out that Socket.io doesn't really like to open lots and lots of connections and other issues. But anyways, the idea behind this is that there's a backing Heroku app, and so there's also a whole server-side component where this is subscribed to an event stream, and originally events were coming in the event stream, and this would poll it itself over a GET request. But the Electric Imp actually runs a server-side thing, so I had to change that to every 3 deploys, it posts to an endpoint in imp land, and then that like unique URL then sends the data down to the imp, which writes it over UART, software serial to the Arduino, which can then read the characters and say, aha, I found a comma. I will now print the name. So part of the internet side of things is you might have questions about, should I use Ruby or JavaScript? Should I use Postgres or Redis? Should I host on Amazon or Heroku? How am I going to operate this thing? This is where I spend my whole day, so I'm happy to help people with questions like that and how they want to set up the server side and the internet connection for their app. And that's it. Thank you.